Alright guys, so today we're going to be doing one of my very favorite things, which is writing in binary. Woohoo! If you get stuck, there's something in Moodle for you. It's called Assistance with Conversions. And the two that we're focusing on today is the converting from decimal to binary and converting from binary to decimal. So this is part 1. Part 2 will be the later ons. As some of you know, right now you usually count in decimal. All of your numbers are decimal numbers, which is base 10. I would recommend even making a OneNote kind of like this, just so you have these notes for yourself. The reason we use base 10 is because we have 10 fingers. That's kind of how we learn to count. So binary is base 2. Binary is base 2. Octal is base 8. And hexadecimal is base 16, because hex is 6 and decimal is 10, so base 16. So octal and hexadecimal we're going to focus more on in part 2. Today we're mostly going to focus on decimal and binary. And the reason we use binary is because it switches. It's on, off, yes, no, and it's kind of how computers operate within themselves. So say you have the number 5,371. You may recall way back that this is the ones place, the tens place, this is the hundreds place, this is a thousands place. So this is 10 to the 0 power, 10 to the 1, 10 squared, 10 cubed, and it would go on and on and on and on and on. So for decimal, we're working in base 10, which means each spot is how many tens there are, or how many versions of the tens. So like this is 5 thousands, 3 hundreds, 7 tens, and 1 one. Binary works the very same. So if you notice, none of these numbers are 10. These are all less than 10. With binary, you're only going to have two numbers, 0 and 1. You'll never see it, just like how you never see a 10. So what if you had a binary number? I'm going to insert some space here. If you had a binary number that was like 10101001. Alright, that may not mean anything to you. Doesn't mean anything to me right now either. It's a binary number, obviously, but that's it. So what we need to do is we need to figure out what it actually is in decimal. So we would say like this is binary and we go to decimal. Alright, the way we figure it out is this is 0 spot, 1 power, 2 squared, 2 cubed, 2 to the 4th power, 2 to the 5th power, 2 to the 6th power. So it's basically saying how many of them are in that spot. So 2 to the 0 power is 1, 2 to the 1 power is 2, 2 squared 4, 8, 16, 32, 64. Look familiar? That's all it's saying. So what it's saying is we have 164. We have 0 32s. We have 1 16. 0 8s. We have 1 4. We have 0 2s and 1 1. So 64 plus 16 is 80. 4 plus 1 is 5. So our answer for this is 5. So this is how you would write the number 85 in binary. Let's try this again. So whenever I write this, I like to kind of space it out a little bit, just so I can put in my spots. Okay. There's my number. It is 111110. 1, 2, 4, 8, 16, 32, 64. You know what? We did that last time. Let's put another one there. The front. So we have 128. Alright. So you may notice I started from the left and worked my way right because I know how to better multiply by 2 than knowing off the top of my head what 2 to a power is. So now we come down and we need to convert from binary to decimal. So we have 128, 164, 132, 116, 18, 14, 12, and 01. So I don't even need that plus right there. Okay. 128 plus 64 is 192. All right, 32 plus 16 is 48. 8 plus 4 is 12 plus 2 is 14. All right, 192 plus 48 plus 14 is 62. So we get 254. So converting from binary to decimal does not get harder than this, as long as you can remember to set it up like that. Now, we're going to go over converting from decimal to binary, which you could do this way too, just backwards. So if you have the number like number 28, all right, so you could set up. Some people like to draw a table for it. If you want to, you can. You don't necessarily have to, but if it helps you to do so, you can do so. That's kind of what we did up there anyway. So this is my 1s, 2s, 4s, and then we don't need the 32s because 28 is below 32. So obviously there's 116 in there. So now we took a 16 out of this, so now we're at 12. So there's an 8 in that. So now we're at 16 plus 8, so we're at 24. We need another 4 to get up to 28, and 02s and 01s. So our answer would be 11100. This is all well and good, especially if you have smaller numbers. But what if you had a much larger number? Say you had a number like 507. Okay, so we have a nice little number, 507. Frankly, I don't want to sit and think about all the numbers that add up to it, so I'm going to show you a trick. If you remember your long division, this will be a little bit easier for you. If you do not remember long division, it's not necessarily harder to remember, but you'll need to remember how to do it. So we have 507, and I'm going to do this the reverse way. So I'm going to make kind of a chart going down. It's going to look like a tree. So 507, and we're going to divide it by 2. 507 divided by 2 is 253 with a remainder of 1. All right, you need to write your remainders out to the side. You divide this by 2. 253 is going to be 126, remainder 1. So far we're doing okay. We're just dividing by 2. Everyone can divide by 2. Divided by 2 is 63, remainder 0. Divide this by 2 is 31, remainder 1. And if you don't want to write the R's, one thing that you can do is you can just move this right next to it so you can all see it right next to each other. So 15, remainder 1, divided by 2 is 7, remainder 1, divided by 2 is 3, remainder 1, divided by 2 is 1, remainder 1, and 1 divided by 2 is 0, remainder 1. So we have all these numbers over here. So what you do now, you read going up. So your answer is going to be 111, 111, 011. And you can always check this going back to the strategy we used at the very beginning of this lesson. Okay, so you are now ready on Moodle. Are two worksheets. One is converting from binary to decimal, and one is converting from decimal to binary. Now, I recommend actually learning how to do it, not just calculating it, because otherwise you will not be well on the test.